In this video, we are going to look at one of our forecasting techniques, which is exponential smoothing. Exponential smoothing is a little bit more advanced than some of the more simple measures that we may have, things like simple averages or even moving averages or weighted averages. It's a little bit more advanced than that. It's certainly not one of our more advanced forecasting techniques, but it's one that you should know, and it may be the right technique for you depending on your situation. So we're going to walk through an example in this tutorial of how to calculate, how to use the formula. And I've got some cheats to kind of put it in English for you if you're unfamiliar with how the formula actually works. But first, let's just take a look at the data and what we're trying to solve. So the only thing I really have in this challenge that I've made up is actual demand for some product in some way. Doesn't matter what it is. But really what I'm trying to get us to do here is solve what the forecast would be for period 8. And again, we could take an average of what's happened in the past. And in this case, as I look down, the average is about 156 units. We could say that for the period 8, it's 156 units. We could do, a moving average of the last 3 months, and that equals an average of 150. Maybe we put 150 in there. But using a smoothing constant and the technique of exponential smoothing applies a weight, what we call an alpha, or smoothing constant, applies a weight more or less to what's happened in the past versus what is likely to happen in the future. That may sound a little confusing, but let's take a look at the concept itself. So the idea of exponential smoothing is that we are going to put different weight on observations over time. So maybe we're going to pay more attention to what's happened recently, or we're going to pay more attention to what's happened in the past. Now, the idea behind exponential smoothing it is not complicated, but it does require you to make a judgment call. And that judgment call is picking an alpha. And all that an alpha is our smoothing constant that we use for the formula. It's a way that we taper the effects of both the forecast and the demand that we have. Again, that may seem a little complicated, but we'll show you how we use it in the formula. So picking an alpha is really, again, it's a judgment call. And you will always pick a value between 0 and 1. That's it. There's nothing negative. There's nothing above 1. It is simply a value that falls in that scale between 0 and 1. And typically, we just do it to 1 decimal place. So 0.1, 0.2, 0.8, 0.9, or 1.0 and 0. Okay? The closer that a number is to 0, the more confident you are historically that demand is going to remain constant for the future. So if you have very constant demand, you would pick an alpha that is a little closer to the 0 and maybe 0.1 or 0.2. If you have these wild and erratic swings and you can't explain them, you're going to pick an alpha that is closer to 1. And all that's going to do in picking an alpha closer to 1 is going to say, hey, listen, I've got to rely more on more current data than I do on the past. And so you can see by contrast, picking an alpha closer to 0 says, hey, I'm going to rely more on what's happened in the past with our forecasting than maybe what's going on right now. Okay, so all it is doing is trading off weights of what it's going to put more value on in our formula. So let's go back to our table here that I've put together. And again, we're trying to solve for period 8. We're saying, what would the forecast be? And we're not going to use those simple averages and weighted averages and moving averages. We're going to step it up a bit and use exponential smoothing and see if we can get something that works for us. Again, we won't know if it's accurate until after the actual demand comes in, but maybe it'll work for us. Okay, so we have our data, and in order to get Formula 8, exponential smoothing actually requires you have a forecast for each previous period. So let's take a look at the formula, and you'll see it written a few different ways, but essentially the forecast for the period you're attempting to solve is equal to alpha, you'll see that Greek letter, hopefully I can hover over it here, your alpha times the actual demand or the actual experience of the previous period or the period previous plus 1 minus alpha times the forecast of the previous period. Okay, that may sound intimidating, but when we look at it down here, and I've kind of put it in plain English, let's take a look at what it means. So it's the exact same formula, it's just written out a little different way. Next month's forecast is equal to the actual demand times your alpha value of the previous forecast of the previous period plus the forecast times 1 minus the alpha value. Okay, so what does that look like? So really, we know that if we're trying to create the forecast in period 2, it is a function of using our alpha against our actual demand and using 1 minus our alpha, which we'll calculate in a second, times what our forecast was. Okay? So it's two components. And you'll see that it gives weight. The sum of those two pieces is what ends up making your actual forecast for the next period. So in order to get all the way over here to 8, we actually have to solve all these, but it's not that hard. So let's do them one at a time. Okay, so the formula, now I've picked a smoothing constant here of 0.2. So again, if I go back to our idea about, hey, I have to pick an alpha, if I'm picking something closer to the 0, that means, hey, my demand doesn't fluctuate all that much, or at least I don't believe that it will. Again, this is purely a judgment call. There's nothing right or wrong here, but you do have to pick a smoothing constant. Okay, so I've picked 0.2. So I'm going to simplify this and say that my smoothing constant, or I need my 1 minus my alpha for my formula. I'm going to go 1 minus my smoothing constant. And of course, that is going to be 0.8. Okay, so I've got both the values that I can plug into my formula here. With just these, now I've got everything I need to figure out, okay? And for simplicity's sake, I'm going to keep the same alpha all the way across. I may adjust that over time if I feel that something is going, but for this illustration, I'll keep it constant, which means as I copy this over, my 1 minus my alpha is going to be the same. Okay, so the only decision I had to make here was what is my alpha, how confident I am. Again, 0.2, pretty confident. It's probably not going to be that erratic. So 1 minus my alpha is 0.8. All we're going to do is do a little math here, and we're going to be able to populate the next month's formula and drop it in there. Okay, so really, again, here's the formula in English, if that helps. But essentially what we're going to do is we're going to take the actual demand from the previous period. So we're attempting to solve the forecast for period 2. So the previous period to 2 is 1. So I'm going to take the actual demand and I'm going to times it by our smoothing alpha, our exponential smoothing, or our alpha, okay? So that is step 1. And then the second part of the equation, step 2, so I should put that, not sure why that's changing. Okay, step 2 is to then take the forecast for that same period and times it by the 1 minus our alpha value. Okay, so 108 and then 31. Now really, our forecast is actually the sum of those two numbers. So I'm going to write a quick little formula here that does just that. So I'm going to do the same thing down below. So I'm going to take our actual demand and times it by our alpha. And then I'm going to add our forecasted demand times 1 minus our alpha. Okay, and that will equal 139, and that's the same as what we did down here in our 2 steps, right? So there's 2 components. One, you're going to add some weight to what's happened actually. So 20% of our forecast in this case is going to be what's happened actually. You'll notice that 80% of our forecasted number is going to be based on what we thought was going to happen, the forecast. So again, remember, we go back to our concept. That smoothing constant here says, hey, I'm going to put more weight on what we thought was going to happen versus what actually did happen. And all that smoothing constant does is divide how you're going to create the weights that ultimately create your forecast. See how simple that was? So that forecast becomes our forecast for period number 2. So 139 units. Now, I mean, we already know what the demand was, but again, we have to solve all of our forecasts in our period to get to the last one. So let's do period number 2, and then we'll kind of cheat and copy the formulas over a little bit. So the same thing, we're going to do our calculations where we take our actual demand, times it by our smoothing constant, And then we're going to add in the second part of our formula, which is our forecasted demand, times 1 minus our alpha. And again, all that does is place different weights. And let's see what weights it places. So we'll do the same thing. So this would be step 1. So our actual demand times our alpha. And then step 2 is our forecasted demand, which we already figured out, times our 1 minus alpha. So in this case, it's saying, hey, my forecast is 141. Now, 30 of those units is based on what's happened. 20% of it is from actual demand and 80% of it is from what I thought was going to happen. Again, right? So our forecast for period 3 becomes 141. So I'm going to take that up there, equals 141. Okay, and it really is that simple. So I'm just going to copy this formula over here. Control right. And I got to copy these over at the same time. Okay, so we should delete that one. Okay, so we get all of our formulas over here, and we've done the same math in each one. And now we've created, now the last step is that we just have to do the same thing for period 8. So period 8 follows the same. We're going to take our actual demand times our alpha. Oops, I should put this in parentheses to isolate them. So our actual demand times our alpha. And then we're going to add in the second part of our formula, which was our forecasted demand times 1 minus our alpha. Oops, did I type that wrong? Yeah, I forgot to put my parentheses, but that's okay. Okay, so what that tells us is that our magical forecast for period 8 is actually 149 units using exponential smoothing. Okay, again, guys, it's a different technique than simple averages and simple moving averages. It adds a bit more rigor to it sometimes. Not the trick, but the challenge with exponential smoothing is in choosing your alpha. And again, you may adjust your alpha over time if you see some weird things happening. And really, again, all that's doing is sliding the scale of, hey, I'm really confident with what's going on, or I'm not so confident, and or half and half type thing. Okay, so hopefully that helps understand or give light to that formula. It may help to think of the formula in this way, but certainly, anytime you're using it, you're going to see a formula presented in this type of a format here, not kind of written out in plain English. But if you do it a few times, I'm sure you'll be familiar with how to do it and how to kind of solve for it. The other thing is in choosing the alpha, you just have to remember that you actually may have to back up. And if you don't have forecasted data, you're going to have to do that piece of it as well. Okay? Good luck.